Hey, so I wanted to do a video on AI for a second because I think that enough people are savvy enough on the topic at this point to understand that AI isn't just large language models. In fact, it's not large language models at all. Um, it's an attempt to create, I guess, a collective consciousness. It's definitely going to have layers to it. And the more you get into like neurology and mimicking neurology, I guess, the more layers just become part of the algorithm, so to speak. Um, because at the heart of it, what you are trying to do, whether you're talking about quantum computing or whether you're talking about um, parallel processing or um, specialized accelerators or CUDA, PyTorch, large language models, any of that stuff. Um, Really, what you're trying to do is specialize and accelerate, but you're trying to run parallel processing in such a way that you can get as many true answers as possible as quickly as possible in order to best emulate reality as it is. If that, I think that's actually doing it pretty fair justice. Um, the objective of artificial intelligence is to take all your hardware components, whatever they may be, and essentially inform them all of the same question and derive. You get into like what is true, what is a true answer, and as you are running simulations of reality, you bump into that actual question in actual reality. And when you're trying to emulate reality or um, predict realities in the future, you bump into the truth of reality is kind of gray. There are um, multiple true answers, multiple perspectives, multiple ways to look at a question and an answer in order to answer and question it in different ways. And you can think of it literally like that, like you are observing a character in a 3D realm and your camera is on a 3D axis and you want to perceive your character from every angle possible as they move. So you are adding more depth. You're adding another layer of reality, and as you add another layer of reality, you're adding a more complex question or answer to a increasingly more complex question as to what does the screen look like is your answer. Well, that answer can be many different things depending on how you ask the question, which is part of where's your camera located, and that interpretation of reality needs to be answered in the fastest way possible. And in order to accomplish that, what you need to do, based on what I've learned and what I believe the industry is producing, is a centralized processing unit which can distribute information to sub-processing units that are specialized accelerators. Those specialized accelerators derive rapid answers to that centralized processor's query distribution, and those multiple answers are essentially reprocessed by another accelerated processor, specialized processor. Long story short, what it comes down to is specialized processing units and the rapid dissemination of information between them. As you increase the proliferation of specialized processing units, you are going to intrinsically increase the need for the rapid exchange of communication between them. And that's what ultimately is going to lead to a single board solution. The specialized processing unit on a chip, I forgot the acronym they use for it, but essentially an all-in-one circuit board that has everything on it built in. Blah, blah, blah. Thing is, building that out to scale is, they're doing it right now. The Blackwell is essentially just that, but even then, there's going to be cost and scale limitations. It feeds into the Intel and NVIDIA thing, but I think it's important to articulate the absolute, like, as you increase, you can come out with a TPU, a DPU, NPU, GPU, and have all these processing units that are hyper specialized in a particular type of math, but they need to be able to rapidly communicate with each other, and they need to essentially be modular. At some point, they need to be modular, because not everybody's going to want a $10 trillion specialized OEM computer. They're going to want to Lego their own castle together by need. They're building something to scale. It needs to grow over time, etc., etc. So there needs to be a modularity to it, where it's built on site or built to spec, and designed that way. So seeing what they're doing, how they're working together, and how artificial intelligence actually works on like a mechanical level. Not I'm talking to my computer, but like the computer talking to the computer, and how those specialized processors need to interact with a centralized processor in order to function as an artificial brain. I mean, if you're going to really get into it, then would need to be adaptive in order to really, but they'll do that with the software. Ultimately, in order to emulate an adaptive hardware environment, it needs to be modular. You need to be able to build it out. Essentially, a computer would need to say, we need more GPUs in order to satisfy predictive demand based on what we think our workload is going to be in the future, and then you need to be able to add more of those whatever specialized processors you need to your system in order for it to be an adaptive system. And then as it writes its own code and adapts its software, you essentially become an enzyme in the artificial brain by providing it with the adaptive hardware build out capacity. But that is the rapid communication is more important than the ever increasing levels of specialized processing units. For the most part, if it was in parity, in other words, if AMD had a huge lead in, like, they had the CUDA cores, I'm sorry, the not the CUDA cores, whatever. They had the specialized processors, and they were way ahead of the game, and their framework was the cornerstone and all that. And then the main processing company made a deal with the second player. I would say, all right, well, you're still going to be wanting to go with the best hardware, even if their communication isn't as fast. But it really, like, the future is in the rapid communication between a central processing unit and its multitude of specialized subprocessors, its accelerators. So yeah, that's basically it. That is the hardware breakdown on AI as I see it. It's really, you can have a litany of specialized accelerators, which are processors, but the communication between them and the main processor is everything. Yep.